Hey guys, welcome to Improper Integrals. So the idea of improper integrals comes from how can we take the integral of a function that is unbounded. So for example, if we wanted to integrate something from 0 to 1 of 1 over x dx, okay? We can't use 0 here. That would, number one, it'd be undefined, because when you graph that function, that branch is going to go up to infinity. It's not bounded. There's not one set area from A to B on an interval where you're filling in and taking that area. So we talk about unbounded regions here, and how can we take the area, or excuse me, the integral of those unbounded regions. There are two ways in which an integral can be improper. The interval of integration may be infinite, okay, so the limits of integration they're talking about, or the integrand itself may tend to infinity. So those are the two cases where we see improper integrals. Now, there's three definitions or three things we're going to be looking at when we talk about improper integrals. We're talking about f as a continuous function on these intervals from a to infinity, negative infinity to b, and negative infinity to negative infinity. We'll cover this in example 4, and we'll do these in examples 1 and through 3. Okay, so here's the idea. We define improper integrals as the limit of that integrals. We rewrite it. Okay, so for example, from a to infinity, if you take that integral, if you see that setup, a is a constant, f of x dx is going to equal the limit of b going to infinity of a to b of f of x dx. So they're replacing that infinity with some number, okay? And then if we look here, from it's really the same thing from negative infinity to b, okay? But it just so happens we switch the negative infinity with an a value here because a is approaching negative infinity. So just be careful of that. Negative infinity to infinity really is a combination of both. And the idea is you're picking a number between infinity and negative infinity. So we have two limits here we're defined as from a to c and from c to b. Okay? And our interval, that's our a to b. So we're going to switch that up. So we have the limit as a is approaching negative infinity from a to c of this function. B is approaching infinity for that limit. And c to b is the limits of integration of f of x dx. So these are the definitions. We're going to use this to help us take the integrals of improper integrals, okay? And the idea is we're using the limit definition on an integral. So, first example, we have, it's got a little messed up there, we'll go like that, there we go. The integral from 1 to infinity of 4x to the negative 4, okay? So, here's what we're going to do. We're going to apply the definition first, is what I did. The limit as b is approaching infinity, and notice I switched my infinity with b of 4x to the negative 4 dx. So I apply the rule, then I take the integral. So here I just wrote the limit as b is approaching infinity. I take the integral of 4x to the negative 4th, and this is what I get. And I've got to evaluate that from 1 to b. So I do that in the next step. Notice I switch x with b and 1. So negative 4b to the negative cubed minus negative 4/3 to the negative cubed. I can clean that up, which is what I did here with some algebra. The limit as b is approaching infinity is negative 4 over 3b cubed plus 4 over 3. Now, what happens when we put a very large number in the denominator? This first term goes to 0. It becomes 0. Put a million in there, it's going to go to 0. It's going to get so small it's going to be non-existent. So the limit as b is approaching infinity is 4/3. When our limit approaches that number, we say it converges. And we'll talk a little bit more about that soon. My second example, which I love, it's the integral from 1 to infinity of 2x to the negative 1/5. And we lost a dx there, okay? It's not going to get you the same answer. We're going to get something that diverges. Okay, I probably got out of the way so you can copy that, right? It's going to diverge. So let's use the definition. The limit as b approaches infinity from 1 to b. Again, I switched b and infinity of 2x to the negative 1/5 dx. I applied the limit definition. Then I integrate. So here's the integration of 2x to the negative 1/5. It becomes 5/2 x to the 4/5. And then I got to evaluate from 1 to b. So I go ahead and do that. The limit as b approaches infinity, 5/2 b. There's that f of b minus f of a idea right here. When I simplify that, I get 5/2 b to the 4/5 minus 5/2. Now, unlike here where b was in the denominator, this is out front. I put a really large number in there. It's going to get really large. That limit's going to infinity. We call that diverging. Okay? So, let's look at a couple more examples. 2 approaching infinity, the integral of 2 going to infinity, from 2 till infinity of dx over x cubed dx. So, by definition, limit as b is approaching infinity from 2, we can go ahead and switch that. We can call that b if we wanted to, which I did in the step below. I guess I could leave that. By definition, here we go. We have the limit, same thing here. I made it infinity go to b, and then I just rewrote 1 over x cubed as x to the negative third. So I rewrote the integrand. I take the integral now, integrate, and I get negative x to the negative 2 over 2, and I got to go from 2 to b. So I go ahead and simplify this out. If I plug b in, and then I plug 2 in, but we're going to go ahead and get negative 1 over 2b squared minus negative 1/8. That's what happens when you plug in 2. Okay, but the first part is going to go to 0 again because you put a very large number in that denominator. It's going to go to 0. So we converge again to 1/8. Again, how we get that is if we put 2 in here, it actually goes to the bottom. So you get 2 squared times 2, which is 8. Okay. Our last example is it's the big one. It's the one going, our integral's going from negative infinity to infinity. And we're going to go 4 over 36 plus x squared dx. So the idea first, let's introduce a constant, some constant c that's between negative infinity and infinity. So we have our choice. We'll call it c. So we go from negative infinity to 0 of our function plus 0 to infinity of our function. So I apply the definition, and by that I mean we're applying the limit definition. So there it is again, straight, there's the limit definition. The only thing I really added to that is the limits here. Okay, and I went from negative infinity, I changed it with a, and then b I changed with infinity. So slight things that are going on here. I had the limit and I changed my limits of integration. Okay, so we pick that number 0, and then we end up changing infinity and negative infinity with our a and b values. Okay, so the next step down, I did some algebra. I just brought the 4 out front in each because I know that the definition, the integral of du over a squared plus u squared is inverse tangent. So now I'm going to integrate this piece and this piece, which is what I've done here. I have the limit as a is approaching negative infinity of this. I have to integrate from a to 0, plus the limit of b approaching infinity of 1/6 inverse tangent of x over 6 from 0 to b. So I have to integrate that. So this blue step here is I integrated the function, and I had that rule. I applied that inverse tangent rule, and I took the 4 out front. It was common, so I brought it out front. Now we'll just clean up the algebra. So we have the 4 out front. 1/6 tangent and inverse tangent of 0 over 6 minus 1/6 tangent a negative 1 of a over 6 plus 1/6 tan inverse of b6 minus 1/6 tan inverse 0 over 6. So here is the f of, here's from a to 0, or a to 0, right, whoops, right there. And this right here is from 0 to b. Okay, so I go ahead and do that. Now, inverse tangent of 0 is 0, so notice how just the negative 1/6 is here. This is actually going to cancel out, and this is going to cancel out. Inverse tangent of 0 is 0. So here's what I'm left with after the simplification. Okay, now I have to say, well, when does tangent go to negative infinity? And if you think about the graph of inverse tangent, okay, or tangent, I guess, what angle, where do we go? The angle that gives us infinity and negative infinity is that pi over 2 and negative pi over 2. Look, here's where tangents go to negative infinity and positive infinity, and that's what I substitute right here, right? Because if I put a very large number in for a, I'm going to negative infinity. If I put a very large number in for b, I'm going to positive infinity. Okay, so that's where these two values come in, and then it's just algebra from here, and I get 2 pi over 3. So that's how we take the integrals, or improper integrals. Okay, we use the limit definition, and there's some rules that we have to do. If you guys have any questions or comments, please type them below, and we'll see you next time.